Good afternoon, class. We are looking at section 5.4, right triangle trigonometry. So in this section, the objective is to solve right triangles and solve applications. A quick reminder of what you have seen before, properties of trigonometric functions, fundamental identities that you've seen. X squared plus y squared equals 1 is the unit circle. A point has coordinates x or cosine theta, y or sine theta. All trigonometric functions are periodic with the period of 2 pi. Tangent and cotangent have a period of pi. All trigonometric functions are odd functions except cosine and therefore secant. Here's the fundamental identities, Pythagorean identities, quotient identities, reciprocal identities, and we've added sum and difference formulas. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. Double angle formulas come very handy. Sine of 2 alpha is 2 sine alpha cosine alpha. Cosine 2 alpha can be represented in 3 different ways. Cosine squared alpha minus sine squared alpha, 2 cosine squared minus alpha, and 1 minus 2 sine squared alpha. Tan 2 alpha is 2 tangent alpha, 1 minus tan squared. And so from this formula, when you solve for sine squared alpha, you get 1 minus cosine 2 alpha over 2. For half angle, just cut this in half, 2 alpha becomes alpha. From here, cosine squared alpha is 1 plus cosine 2 alpha divided by 2. Cut this in half, 2 alpha becomes alpha. And tangent simply is the ratio of sine to cosine, so tan squared alpha is the ratio of sine squared to cosine squared, and the same thing for its half angle. And you have sine alpha over 2, for example, from here, plus minus the square of 1 minus cosine alpha over 2, and the rest of them. And bear in mind, as far as positive and negative, you make a decision based on the location of a quadrant. And these are some more formulas, product to sum and sum to product formulas. For example, sine alpha, sine beta is half of cosine alpha minus beta minus cosine alpha plus beta, and the rest. Now, in the case of a right triangle trigonometry, what do we need to know when we want to solve a right triangle? One angle is 90 degrees. So this is A, vertex A, vertex B, vertex C. Across from vertex A, it's side A, lowercase, represents the side. Across from vertex B, capital B, is lower b, side B. And across from vertex C is lowercase c, the side C. These two are the legs, and this is the hypotenuse, the largest side. The larger the angle, the larger the side opposite that. As you know, according to Pythagorean theorem, a squared plus b squared equals c squared. And because this is 90 degrees and all the interior angles add up to 180, these two must add up to 90. So a squared plus b squared equals c squared. A plus b must be 90 degrees because the total interior angles add up to 180 degrees. If we call this angle theta, we normally call it angle B, but either way is fine. Then we have the following definitions. Sine is the opposite over the hypotenuse. Cosine is the adjacent. So for this one, the adjacent would be this one over the hypotenuse. Tan is the opposite over the adjacent, and the rest of them are the reciprocal of the top three. For example, for sine theta, we should figure out what's happening here. Opposite, we're talking about this angle, theta or B. You can theta or B. And do a good job on that. B. In that case, the opposite is what? B over the hypotenuse C, so B over C. What about cosine theta? The adjacent A over C. Tan theta, the opposite over the adjacent, B over A. And the rest of them, as I mentioned, they are reciprocals. Find the value of each of the 6 trigonometric functions of the angle theta. Reminding everyone that a squared plus b squared equals c squared, a plus b is 90. And because this is 90, the two must add up to 90. And if this side is 3 and this side is 5, this side must be 3 squared plus b squared equals 5 squared, and we can find that easily. So let's call this side b. So this is a, this is c. And so 3 squared plus b squared equals 5 squared, which makes b squared equals 16. And b is 4. So we found all the sides. Now, what is sine of theta? The opposite, which is 4, over the hypotenuse, which is 5. What about cosine theta? The adjacent, which is 3, over the hypotenuse, which is 5. What about tangent? The opposite 4 over the adjacent 3, 4/3. The rest of them, just the reciprocals. Cosecant is 1 over sine, and so on and so on. So that they should be no problem. In fact, even tangent is sine over cosine. So divide this one by this one, you get 4/3. Okay, class? So that should do the job, and it shouldn't be any problem. But just in case, if you want to go through the process. So pretty straightforward. We're going to continue looking at a simple example, solving a right triangle where some parts are given, some parts are missing. In this case, A is given, B is given lowercase, and lowercase c is missing, A and B is missing. So if this is A, this is B, that means this must be C. And so C is 90 degrees as an example. And this one is lowercase b across the vertex B. This is the lowercase a across from the vertex A. Okay, so I want to make sure we understand what's happening. Vertex A across from it, lowercase a is 3. Vertex B across from it, lowercase b is equal to 2, and this is 90 degrees. So if we have two sides, we can find the missing side, which is the hypotenuse. A squared plus b squared equals c squared. So that means 3 squared plus 2 squared. This is 9. This is 4. So c is square root of 13 precisely because they add up to 13, right? So we have all the sides. We also have, of course, this angle. All you have to do, just use one of those trigonometric identities. For example, tangent of this angle is the opposite over this, 3 halves. So tan of A is 3 halves. And find A, or you can say tan of B is 2/3, either. So how do we find A? A is the tan inverse of 3 halves. Now use a calculator. And if we stop here, okay, 56.3 degrees. If we stop here, okay, then because of 9, we change it to 1. It depends on how many decimals they want. Normally, they want only 1 decimal for angles, but pay attention to what they want. All right, so if we have one of the angles, the other one should be this subtracted from 90, right? Because these two add up to 90, right? And you get 33.7. Now let's put all of them together. It's a good practice to make sure you have all of it. So capital A, we found it to be 56.3 degrees. Capital B, those are angles. 33.7 degrees. Capital C, we know it to be 90 degrees. Lowercase a was given. Lowercase b was given 3 and 2. And lowercase c was found to be square root of 13. So this is organizing it in essence. Another example where B is 2, A is 40, find A and C and B. And sometimes this is not given. You got to figure it out on your own. It's not that big of a deal. So let's see what we have here. So A is 40 degrees. I want to do something here. I want to say this is vertex A. Okay, this is 40 degrees. This says it's vertex B, and therefore this must be vertex C. Now look, across from capital C, lowercase c, across from capital A, lowercase a, across from capital B, lowercase b, and that's given. So just to give you an idea. All right, obviously this is 90 degrees, this is 40, they must add up to 90, this becomes 50. That's as simple as it gets. That's the first one we would tackle because it takes a split second. 40 plus b must add up to 90, b must be 50 degrees. And we have only one side, so we can't use Pythagorean theorem, but rather we're going to use the fact that we can calculate tangent, sine, cosine, one of them. It doesn't matter which one you calculate. Okay. For example, we can say, and normally use the one that is given. In this case, this one is given. So first, B is 50 degrees. So let's change this to 50 degrees so it becomes clear. And now tan of this one is the opposite over the adjacent, A over 2. Which means we can use the cross product. One times A is 2 times tan 40, and I'm reminding you of the proportion and therefore cross product. So 2 times tan 40 is A. Now tan 40, now use a calculator. And by the way, when you use a calculator, you make sure this is in degrees, not in radians, because it's given in degrees, and it ends up being about 1.68. Now, can I use a squared plus b squared equals c squared to find the missing c? Yes, you can do that. But always try to use what is known. Now, 40 degrees is known and 2 is known. You know cosine of 40 degrees is the adjacent 2 over c. So again, this is not the only way. So this is 1.68. Cosine of 40 equals 2 over c. That would be a better course of action just because what is given. And in case we made a mistake here, we don't want to make a mistake here. So again, we do the cross product. Okay. And the other technique that I can teach you, just to remind you, you can interchange this one. You can say C is 2 over cosine 40. Okay. You can do that. That means really, in essence, you are doing the cross product. So with that being the case, 2 divided by cosine 40 using a calculator at 2.61. Again, as far as the number of decimals, if they are not mentioned, use as many as you want. So let's write the synopsis of what we came up with. So this is 261. A was given as 40. B was found to be 50. C, 90 degrees, capital. Capital represents the angle of vertices. Lowercase a found to be 1.68. Lowercase b was given as 2. Lowercase c was found to be 2.61. Just in case this is A, this is C. Complementary angle. Sum is equal to 90 degrees. So we are looking at complementary angles. There's the S here. So two, I hope you remember that from algebra, two angles are considered that you've studied in geometry and algebra. Two angles are considered complementary if they add up to 90 degrees, supplementary if they add up to 180 degrees, and so the other expression would be co-function of complementary angles are equal. Now, what are co-functions? For sine is cosine, for tangent is cotangent, for secant is cosecant, as long as the sum of their angles is 90 degrees. So take a look at this one. Sine of 30 would be cosine of 60 because these two add up to 90 degrees. So if you look at the definition of those trigonometric functions with respect to a right triangle, over here, if you look at B, the adjacent, this is considered adjacent to A, opposite B. This is called considered adjacent to B, opposite A. So just for the sake of argument, if you want sine of this one, sine of B, just for the sake of argument, let's write B here. If I'm interested in sine of B, okay, is B over C. What if I want cosine of A. Cosine of A is the adjacent to A, B over the hypotenuse. You see these two are the same. Okay, and that's the idea. And you can figure out the rest of them as well. For example, if you want tangent, let's write that one also. Tan of B is the opposite, which is B over the adjacent, which is A. Now cotangent A is the adjacent to A, which is B, over the opposite, which is A. So you can see that these two are the same. So I hope you can see that. Therefore, if they add up to 90 degrees, sine is cosine. They add up to 90 degrees, tan is cotangent. If they add up to 90 degrees, secant becomes cosecant. Okay? So, for example, let me erase my work. I want sine of 62 degrees. That is cosine. Cosine of what? Subtract this 90 minus 62 degrees and becomes cosine. So cosine of 28 degrees. What about tan of pi over 12 becomes cotangent of what? 90 minus pi over 12 meaning pi over 2 minus pi over 12. And as you know, pi over 2 is 6 pi over 12. So becomes minus pi, 5 pi over 12. Cosine of pi over 4 is sine of pi over 2 minus pi over 4, which happened to be pi over 4 again. Cosecant becomes secant pi over 2 minus pi over 3, and that becomes pi over 6. This is pi over 6, everybody, I thought. Pi over 6. Well, they must add up to 90 degrees. Okay. Solve applied problem. A surveyor, example 5. A surveyor wishes to find the width of a river. So we want to find it. He sets up his transit, an instrument that measures angles, at C on one side and sighted across to point A. On the opposite side. After turning through an angle of 90 degrees, so turns 90 degrees, he walks 200 meters, this distance of 200 meters from C to a point B. And finally, setting the transit at B, he measures the angle A, B, C, or theta to be 20 degrees. So this angle is 20 degrees. What is the width of the river? This is one simple application. Well, tan of theta or tan of angle ABC is the opposite B over A. And we know theta is 20 degrees. So tan of 20 degrees. And we know A is 200 meters. One times B is B. And you multiply these two. Of course, you look up tan 20 using a calculator, and it gives us the B, the width of the river, to be 72.79, the same units, meters. Okay, class, the same units. Angle of elevation and depression. Here's the definition. Angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So you're looking at something, the angle it makes with the horizontal plane, that is the angle of elevation, line of sight, the object, horizontal plane. Very straightforward. So that's the definition. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. So this was above, this is below. So here's your line of sight, here's the horizontal plane, and we are looking at the angle of depression this way. So between the horizontal plane and the line of sight. Don't make a mistake. It's not this angle, it's this angle, this one, and the line of sight. Always the horizontal plane and the line of sight. In other words, as an example, take a look at this interesting one. So there's a cat, there's a bird. The cat is looking up. So this is the angle of elevation. The line of sight, horizontal. From the bird's point of view, here's the horizontal, here's the line of sight, angle of depression. Also, this is a good example. So you're standing here, you're looking at an airplane. So here's the horizontal plane. So looking up gives you angle of elevation. Here's a dog, looking down is an angle of depression. So that should be helpful to see what's going on. Here's a simple example. So applied problem. Meteorologists find the height of a cloud using instrument called ceilometer. A ceilometer consists of a high projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. So that's what we have. Now, a ceilometer was set up such that its light projector is 300 feet from its projector. If the angle of elevation is 75 degrees. Find the height of the cloud. Let's see what we are discussing here. So we have the vertical light. Here's the cloud height. We are interested in this height. Here's the light detector. Here's the angle of elevation, theta. And here's the distance. So let's plug in the numbers. So this angle, 75 degrees. This distance, 300 feet. So I hope it's clear to everybody. Angle of elevation, 75 degrees. ,300 feet from the projector. So basically this is the case, and let's just rewrite it in this fashion. So this distance is 300 feet, this angle is 75 degrees, and this height is missing. That's it. Therefore, all we have to do, this is theta, remember that. Tan of theta is h over b. Tan of theta is h over b. H is missing, but tan of theta is tan of 75 degrees, and b is 300 feet. So h becomes the product of these two, 300 times tan of 75 degrees. You use a calculator to find tan of 75 degrees. Multiplication by 300 gives you the height. Again, same unit in feet, 1,119.62 feet. Let's look at this example. The statue of Ceres, the Roman goddess of wheat, can be observed at the top of the Board of Trade building in Chicago. Observations 400 feet from the center of the building, 400 feet, reveals that the elevation to the base and to the top of this statue are 55.1 degrees and 56.5 degrees respectively. So angle of elevation, so this is the statue that has some height. The base gives you an angle, and which is a tad smaller, 55.1 degrees. Then if you look at the top of it, that gives you an angle of elevation which is slightly more, 56.5 degrees. What is the height of the statue? So we want to find the height of the statue. I hope you can see that if you drop a perpendicular here, from the base to this is 1, we can calculate, and from the base all the way to the top of the statue, we will get the following. So 55.1 degrees, the smaller angle gives us the base, okay? And 56.5 degrees, the larger angle gives us the top of this statue. So in short, the difference between the two is the height here. I hope everybody understands what we're talking about here. So if we call this B prime and we call this B, we want B prime minus B. That's the bottom line. So each one, we can use a tangent on that. Tan of 55.1 degrees is B over 400. And So B is the product of these two. Using a calculator, we get 573.39 feet. So from the bottom of the building to the top of the building, which means the bottom of the statue, is this much. Now for this one, tan of this angle is B prime over 400. And so B prime is the product of these two now. Putting a calculator gives us 604 feet and 604.33 feet, which means from the bottom, from the base of the building to the top of the statue is this much. So the difference between these two must be the height of the statue. Subtract this from this one. B prime minus B is 30.94 feet. So almost 31 feet.